Hi Shiva, good morning.
Good morning. Yeah, let me share my screen. Is that my screen visible? Can anyone confirm, please?
Yes, it's visible.
Thanks for that. Okay, now. Okay, let's go through the introduction part. Okay, today. So this course is for Docker and Kubernetes, where we go into different types, different concepts in it, and how the industry uses the Docker and Kubernetes. And yeah, the content I'll also show the content today, and what we are going to see, different concepts and different type of debuggings, such kind of things we are going to do. And let's go through the intro first. Okay, first let's go through my intro. Okay, so my name is Shiva. I have 8+ years of experience in industry. So I work for multiple technologies like AWS, Jenkins, Terraform, Docker, Kubernetes, Python, Groovy scripting, and Spring Boot applications, developing microservices with Java and something like that, and debugging some of the problems appeared in the production as well. So I hold multiple certifications. Okay, AWS Developer Associate, one of the one, and Certified Kubernetes Administrator, and Terraform Associate. So this is a short introduction of myself. Okay, so yeah, now what are the prerequisites that is required in joining this course? Let's go through one by one actually. So duration of this course will be 5 weekends. Okay, duration of this course will be 5 weekends, and we are going to start from very scratch. When I go through the syllabus, you can understand, okay, from where we are starting the course from very scratch here we'll be starting, so that anyone will be understand easily. Okay, anyone can understand easily. Okay, so only one requirement, one prerequisite that is required for you is the AWS account. Okay, because not only in only AWS account, you can use the Azure account and Google Cloud accounts as well. So but one cloud account is required. Okay, everything I'll be showing in the AWS account, because Docker and the Kubernetes are the huge softwares that should be installed in order to complete our labs, right? So if you install those softwares in your local machines, then that may affect other applications which are running in your local machine. So that's the reason why I'm saying to create an AWS account or any cloud account to practice our labs, like to perform our labs actually. That's the thing. And if you want to install Docker in your local machine, your requirement, like your laptop machine requirement, should be 4 GB RAM at least. Okay, that should be there, because if it is less than 4 GB, then it is not going to work. Okay, so because it will be giving some troubles for you. Okay, so that's the thing. That is the reason I have told you to create an AWS account. That's only the prerequisite that is required. And how to create this AWS account and all the other things I'll be showing you how to do that. Okay, so that's the thing. Who can join this course? Freshers, because I'll be going through the course content today, and you can understand from where we are starting the course and from at what place we are in the course. Okay, any freshers, okay, experienced people, developers, testers, DevOps aspirants, Linux admins, and who want to learn Docker and Kubernetes, and DB admins and non-IT students, anyone can join this course. It's that understandable and that explainable actually. So that's the thing. Any graduates can join this course. What are the benefits of joining this course? Is doubt clearing sessions you are going to get in the regular classes, and fully documented notes. You are going to get the documented notes and full hands-on sessions. Okay, everything, each and every concept in this course will be hands-on. Okay, we are going to make our hands dirty in order to complete the course. And each and every concept will be hands-on. First we will be discussing about theory part of that concept, and then we will be discussing about the diagrammatic part, because like if you then we are going to understand about the labs part actually. In that manner we are going to complete. Okay, so 5 different projects we are going to have. Okay, so some are from Docker and some are from Kubernetes. We are going to integrate some of the different things of Kubernetes, like Kubernetes dashboard, Helm, and like we are going to see the course content. Okay, interview questions you are going to get. Okay, you see interview questions also you are going to get. What are the different things that I may ask in the interview? So that kind of questions you are going to get, and that's the thing. Okay, we will start this course from very basic level, and we will be completing this course at very advanced level. Okay, so that's the thing. Okay, daily, like it's from Saturday and Sunday, it's weekend batch. Okay, 2 hours class from 8 a.m. to 10 a.m. morning. Okay, it may be 1.5 hour also, like 1.5 hour to 2 hours batch. So 8 a.m. to 10 a.m. actually. So that's the thing. Okay, so every Saturday and Sunday. Okay, course content I'll be going you through this today, and contact information. Like if you are facing any non-technical issues, like accessing drives, and like you are not able to see the videos, like uploaded videos to the drive, something like that, you can contact these mobile numbers, and these are email ID you can mail to them. Okay, so the course which you get the access, like it may be the documentation and it may be the video content, you will be having the access of 6 months of duration actually. So that's the thing. Yeah, that's the thing. Then now we will be going through the course content. What are the different things that we are going to do in the course? Okay, so this is a course content. This is a course content. Okay, you need to first know what we are learning in this course, so that you will be understanding the importance of this course. Okay, so that is why I want you to go through the course content first. So let's go through that. Okay, so you can understand from where we are starting this Docker and Kubernetes. Okay, from SDLC process. Okay, what is SDLC? So we are starting this course from what is SDLC and what is DevOps. Okay, what is DevOps? Where is DevOps position in SDLC, and importance of DevOps in software release process. So you can understand from where we are starting. It is very basic level, and that's the thing. That is why anyone can join this course. Okay, Docker and Kubernetes position in SDLC. What is the position of Docker and Kubernetes position actually? Where does this Docker and Kubernetes fits in SDLC process? Okay, that we are going to discuss. Importance of Docker and Kubernetes in IT industry, because of the like evolution of microservices in the industry. Docker and Kubernetes has high demand in market, and people are looking for the Docker and Kubernetes aspirants actually. So that's the thing. Okay, introduction to physical server virtualization and virtual servers and cloud actually. So people used to deploy the applications on physical servers. What are the disadvantages that we have to in order to, like if they deploy their applications on the physical servers, then how the virtualization is evolved because of the disadvantages that we have with the physical servers, and what are the disadvantages that we have with the virtual servers and virtualization, why we went to Docker and why we went to cloud, from why we went to Kubernetes. In that manner, we will be understanding one concept. What are the disadvantages are there with that concept? Because of that disadvantages, we went to other concept, and the other concept will also having some disadvantages. And what are the disadvantages that are like because of those disadvantages that other concept has, we are going to other concept. In such manner, we are going to understand the course. Okay, in such manner, we are going to understand, so that you will be very clear with the course actually. So introduction to physical servers, virtualization, virtual servers and cloud. Okay, these are the introduction parts. Okay, so Docker introduction, here is where Docker introduction starts. Okay, introduction to Docker and containers. Okay, so what is Docker and why we use Docker, why we call as containers, and what is inside the container. Such kind of introduction things will be going on, and installation of Docker and Docker Compose. So Docker Compose is one of the tool where we automate the deployment of Docker, our applications of Docker container with the Docker with the help of Docker container. So if you want to deploy like 100 applications, you need to run 100 different commands of Docker, but with Docker Compose, only one command, 100 applications will be deployed at a time. Okay, that's a that's the power of Docker Compose. We are going through the Docker Compose files, creation of Docker Compose files, manifest files. So such kind of things all we are going to do. Okay, so explanation of YAML syntax. Okay, this is a YAML is a like declarative syntax you need to understand in order to write this Docker Compose files actually. So in the Kubernetes as well, if you want to write any manifest files of deployments or whatever it is, so you need to understand the YAML syntax, okay, that we are going to look, okay, in the Docker introduction itself. Okay, so explanation of technical terms that are used in the Docker. Okay, so if like before going into the deep diving of the Docker, if you understand what are different keywords that we use in the Docker, like what is Docker host, we call it as, why we call that as Docker host. Okay, what is Docker client, okay, what is Docker client, okay, what is Docker daemon, and what is Docker registry, and what are Docker images, what are Docker containers. So something like that, if you understand these keywords prior to going into the course, then it will be very easy for you why we are calling that component as this with these names actually. So we are going to understand in that manner. Okay, that's the thing. Okay, now then Docker deep dive in the Docker deep dive, commands used in Docker and their application explanation along with the flags. Okay, we have different commands that are used in Docker, and along with the commands we are going to use some flags in those commands actually. So explanation why, what is mean by -p, okay, what is mean by -d, what is the meaning of capital P, what is the meaning of small e. Okay, such kind of clear explanation will be there. Okay, that's the thing. Now working on Docker images. Okay, like we can create our own images and we can use the images that are there in the Docker registry. Okay, so that's the thing. So we will be working on Docker images actually. Okay, that's the thing. Okay, so maybe I'm using some of the technical keywords, please bear with me because I need to explain the course content for you. Okay, that's the thing. Okay, now practical examples of running applications and use cases. Okay, we are going to run applications with Docker images, and all the in the practical actually. So understanding the three-tier architecture, like what is a three-tier architecture? Front end, back end, database. So front end should be communicating with the back end applications, back end should be connected to database to fetch the data, and back end should be giving the data to the front end to visualize, to show the data to the users. Okay, so what is the three-tier architecture, why we use three-tier architecture in Docker? So you need to understand this. Okay, that I put here. An explanation of explanation and creating multi-container architecture. Okay, so see, in industry what it will happen, they will not develop all the front end, back end, and database at the single application. What they do is front end one application, back end one application, and database is another application, and they deploy three applications. They need to establish communication between these applications to work well actually. How to establish a communication between the applications that are deployed as Docker containers on the Docker host actually, like that are with the help of -link flag and Docker Compose. And one of the other option we have is Docker networking, that we are also going to see. Okay, so that is thing. Please bear with me because I'm using some of the technical words because I need to explain you the course content. That's the thing. Okay, so practical examples and use cases of multi-container architecture. Okay, we are going to do practical sessions, okay, of multi-container architecture. Okay, all the things will be practical. Okay, custom Docker images. Okay, so in the custom Docker images we are going to create, and like our application will be there, our the Spring Boot application will be there, Java application will be there. So we are going to convert our Java application into Docker image, and we are going to deploy that Docker image to the servers actually. So that's how we create, that's just creating custom Docker images. So if you want to use the existing Docker image, you can use, but how to create custom Docker images, you need to know what is custom Docker images. For your application you need to create your own Docker image. So that's the thing that we are going to, there are different keywords that you need to understand in these custom Docker images in order to create custom Docker images, that we will be going through the course actually. Understanding and creating custom Docker images, understanding the Docker file, what is Docker file, what are the different keywords, explanation of various keywords used in the Docker file, what are the different keywords that we use in the Docker file. Okay, because of the keywords only we can able to convert our application into Docker image. Suppose you developed an application or developers developed an application, you cannot put directly that application on the servers actually. Okay, you cannot directly put up that application on the servers. You need to convert that application into a Docker image in case of microservices. So that Docker image should be deployed on the servers so that your application will be in running state on the servers. Okay, you cannot directly deploy your code. You cannot directly put your code on the servers. That is not feasible solution. Okay, that's the thing. Okay, what is caching? Okay, what is cache bursting in Docker? Okay, what is cache bursting in Docker? Okay, that's what we are going to discuss. Docker volumes and Docker networking. In the Docker volumes and Docker networking, we have two types of Docker volumes in Docker. Okay, simple Docker volumes or like and Docker volume containers. Simple Docker volumes are also called bind mounts. Okay, so that we are going to discuss simple Docker volumes and Docker volume containers. Okay, understanding significance of Docker volumes and its types actually. Okay, understanding Docker networking and its type. There are various networks that are available with Docker: bridge network, host network, that will understand null network, and overlays network. Okay, so practical examples anyway, everything will be practical. Okay, practical examples and use cases with Docker volumes and Docker networking. Okay, that's the thing we are going to see. Docker registry. Okay, so there are two types of what is Docker registry. Docker registry is the place where we store Docker images. Okay, Docker registry is the place where we store Docker images. So there are two types of registry: public registry and private registry. Anyway, we are going to the source. So what is Docker registry? What it does actually? What is a use of it? Why we use the Docker registry? So that's the thing we are going to discuss. Practical examples and use cases of Docker registry, like pushing your application Docker images to the Docker registry and pulling from the Docker registry, downloading it from the Docker registry. Such kind of practical examples we are going to do, and that's the thing. Okay, so as part of advanced concepts and projects, so multi-stage Docker builds we are going to use actually. So what is multi-stage Docker builds? It is used to increase the security in your Docker in your application and decrease the Docker image size. Okay, how to use this multi-stage Docker builds? Okay, how to use this multi-stage Docker builds we are going to see actually. So if what is this multi-stage, why it is used for multi-stage Docker builds? In order to create the custom Docker images only, in order to create your application to Docker image only, but in a advanced manner, like in a secure manner actually. So that's a multi-stage Docker builds. This is highly used in the industry. So that's the thing. Okay, now practical examples and use cases of multi-stage Docker builds: projects on Docker and Docker Compose. Okay, we are going to write Docker Compose file, and we are going to deploy that application on the servers, and we are going to establish a communication between applications, and we are going to access that application from our external browser actually. So that's the thing. Okay, debugging and troubleshooting of issues faced in Docker actually. Suppose we may face different problems when we are going through the course actually. So suppose if you know prior itself what are the different problems that may occur in Docker and how to solve them. Okay, how to solve them, so that it will be very easy for you. If the next time if that problem occurs for you, you can easily solve that. Okay, we are going to create some problems, our own problems, and we are going to see the solutions how to solve that problems. And if any problem appears, okay, if any problem occurs while we creating our applications, then such kind of problems also we are going to solve. That is that debugging and troubleshooting of issues faced in Docker actually. We are going to see how to debug the problems which are occurred in the Docker. What is the step-by-step process? First, what you need to look at, if your application is not running inside the Docker container, so first what you need to do, okay, why it is not running, how to find that, okay, where you need to find that, okay, where you need to look the logs for, okay, how to look the logs for, what is the metrics of that, something like that. Such kind of debugging activities will also be shown in this actually. So because of this, what will happen if you face same problem or similar kind of problem in the industry as well when you are working, so that you will be able to know that this is the problem, this is a solution for it. So why this problem is going to occur, this is a reason why this problem is going to occur. So you need to you can understand like that. Okay, so that's the thing. Okay, next, okay, introduction to container orchestration technologies and advantages. What is container orchestration technology? Okay, what is container orchestration technologies? There are some disadvantages with Docker. Because of the disadvantages that we have with Docker, we are going to container orchestration technologies. So such kind of there are different container orchestration technologies are available in the market. One is Docker Swarm and Kubernetes. Actually, most popular on our Docker Swarm and Kubernetes. Docker Swarm, what are the disadvantages that we have with Docker Swarm? Why we are not using? Why most of the people are? Why most of the IT industries are not using Docker Swarm? We will go through that reasons, and we will be entering into the Kubernetes. Okay, introduction to Kubernetes. Okay, so Kubernetes installation and tools required. Okay, what is Kubernetes? KS is a shortcut for Kubernetes. Between K and S, there are 8 characters. That is why K8S. Okay, so that is why Kubernetes and installation of Kubernetes with Minikube to reduce costs. Because if you install Kubernetes with AWS, that may charge you people. So I will be telling you how to install a Kubernetes clusters with minimum cost. There is a I am going to tell you 3 different ways. One is with the Minikube, and second one is with the KubeADM, and the third one is with the EKS type of clusters. Okay, so that you can decide. I'll be telling you for this much amount of cost, and for this much amount of cost, for other one this much amount of cost. You can decide what Kubernetes cluster you can use. Okay, that's the thing. Okay, installation of KTS client kubectl. kubectl is a client where you can interact with your Kubernetes cluster. How to install that, and where we can find the documentation, how to follow that. So we are going to see that. Okay, so that's the thing. Creating Kubernetes cluster with AWS EKS with YAML syntax. Okay, so there is a YAML syntax, cluster config, something called. So with the help of cluster config YAML file, so that YAML file we are going to deploy automatically with no time. Like automatically the EKS cluster will be created. EKS means Elastic Kubernetes, like that's a service actually. So that's the thing, how to create Kubernetes cluster with YAML file. I'm going to see. Okay, Kubernetes cluster architecture and its components explanation. Okay, what are the different components that are there with the Kubernetes? Okay, what does Kubernetes API, Kube API server does, Kube controller manager, Kube scheduler, okay, etcd, what it does, why it is required in the Kubernetes cluster, and kubelet, kube proxy. Okay, what is container runtime engine? Okay, container runtime engine. So such kind of things will be there. Okay, so explanation of technical terminologies in Kubernetes, because if when we go, before we deep dive into the Kubernetes, you need to understand what are the different technical terms that we will be using in the Kubernetes, so that it will be very easy for you it will be very understandable and easy for you when we go deep to the course actually. So exploring the Kubernetes cluster, like we will be exploring through the Kubernetes cluster, like what are the different namespaces by default available, and what are the things by default available when we create Kubernetes cluster, and such kind of things. Okay, imperative commands and Kubernetes manifests. Okay, so you can deploy your applications 2 types of ways in the Kubernetes clusters actually. One is imperative commands, okay, with the help of commands. Okay, and the other way is the Kubernetes manifest. Okay, manifest means it's a YAML files you are going to write, and generally we are going to write. Okay, we are going to write manifest files, and we are going to deploy that manifest files on the Kubernetes clusters. Okay, so industry used way of thing is Kubernetes manifest, but not the imperative, uh, commands actually. So that's the thing. Okay, now Kubernetes workloads and resources. Okay, how to deploy? There are different ways of deploying the applications on the Kubernetes clusters. Okay, so one, what is containers and what are init containers? When to use init containers in Kubernetes? Okay, when we need to use init containers? Okay, what are pods? What are pods in Kubernetes? Replica sets. Replica set, what is mean by replica set? If one pod has been killed, a new pod automatically comes into picture. Okay, automatically will be deployed, okay, on the Kubernetes cluster. So what is that? Okay, what are deployments, when to use deployments, and what is daemon sets, jobs, cron jobs, replication controller, all such things we are going to see. Okay, Daemon sets is used for collection of logs, deployments is used for deploying our like microservices, such kind of things we are going to see actually. So because of like explanation of annotations in Kubernetes, okay, what is annotations that are there in Kubernetes, why we need to use them, okay, that's the thing. Explanation of multi-container pods, okay, we can run multiple applications in one pod, how to run that, what are the different use cases, why we will run multi-container pods production environments and development environments, what is the actual use case for that. Okay, we are going to see such kind of thing, practical examples and use cases of above workloads, all the things we are going to do in practical. And that's the thing. Kubernetes services and load balancing, okay, what are the different types of services are available with Kubernetes, okay. Cluster IP is one of the service, node port is one of the service, load balancer is one of the service, external name, and like these are the different types of services that are available in the Kubernetes, clusters actually. So when to use cluster IP, when to use node port, when to use load balancer, when to use external name, okay. So such kind of things we are going to see. Understanding multi-port services, okay, multi-port services, practical examples and use cases of service types, services and its types. Understanding DNS of the services and ports, because for like DNS means domain name system, okay. So for each and every service that we create in the Kubernetes cluster, there will be some name allocated for it. So what is the DNS name, we are going to see. How the DNS name is structured, we are going to see. So okay, so maybe I'm going through some of the technical terms, because bear with me, because I need to understand, I need to explain you the syllabus, okay, what we are going to see. Okay, Kubernetes storage, understanding volumes in Kubernetes, what are the different volumes are available, persistent volumes, persistent volume claims, and projected volume, storage classes, dynamic volume provisioning, volume snapshots, something like that. We are going to see all these things, okay. So that's the thing, practical examples and use cases, okay, of storage actually. There are many things here. One of the thing is static volume provisioning, host path, empty dir, such kind of things also there, okay. Practical examples and use case of storage. Okay, what are volumes actually? What are volumes? Suppose your application you deployed on the Kubernetes cluster, that will be generating some logs. Okay, that will be generating some logs. You need to store that logs somewhere, because latter point of time, that is they are used, that logs are used for auditing purpose. Who logged into this application, what actions they performed, did they face any issues, if they face any issues, what issues they face, such kind of like things you will be able to know by auditing the logs of that applications. Okay, how like storing the logs with the help of Kubernetes storage actually. So that's a storage that is required in the Kubernetes. Okay, configuring Kubernetes workloads. Okay, next thing is configuring Kubernetes workloads. Okay, config maps and secrets and resource management for pods and containers. We are allocating some amount of CPU and memory to the pods and containers, how to allocate them and how to restrict them to use this much amount of CPU and this much amount of RAM. You should not exceed this much. You should not exceed 1 GB of RAM, and 1 CPU should not use like outer to this actually. So such kind of configuration we are going to do. Okay, understanding different types of deployments and their significance. Okay, so that's the thing, canary deployment, blue green deployment, and like rolling updates, rollouts, something like that. Configuring horizontal pod autoscaler. What is this horizontal pod autoscaler? Is suppose you deployed your application on the Kubernetes cluster. Okay, you deployed your application on the Kubernetes cluster. Okay, your application is new to the market, and today only 100 requests are coming. Okay, only 100 people are requesting your application or sending the traffic to your application, and tomorrow your application has been popular. Okay, your application has been popular. Okay, so many people, 10,000 people are requesting your application. Based on the amount of traffic, based on the amount of incoming traffic that is coming to your application, your scaling of your application will be happening in the Kubernetes clusters automatically, without you manually interacting, without you manually doing any manual activities in a Kubernetes cluster. That will be automatically scaling your application to handle high amount of incoming traffic. So that is using the horizontal pod autoscaler. Okay, so that one we are going to see. Readiness probe like liveness probe and startup probes. You are going to see these probes are used to perform the health checks for our applications in the Kubernetes cluster. So what are health checks, why we need to perform that also we are going to see. And configuring pods with policies like image pull policy. Okay, image pull policy will be there, like if not present always, never. So 3 policies will be there. What are the different, like what are the meaning of those policies we are going to see. Commands and arguments. Okay, commands and arguments, we need to pass some commands and arguments to the pods actually. So why is the requirement to pass the commands or argument to the to the pods, okay, to our applications, the how to pass commands and arguments in the manifest files that we are going to see. Explanation of namespaces. Okay, what is a namespace in Kubernetes? What is a namespace? Is isolation of your workloads between the in the Kubernetes within the Kubernetes cluster actually. So what is that namespace? Why we need to use namespaces? Okay, so practical examples and use cases, everything will be practical as I have told you. And scheduling. Okay, scheduling, introduction to scheduling in Kubernetes, explanation of how Kubernetes schedules the pods or nodes. Like what is meant by schedules? Like it how the Kubernetes deploys the applications. You will deploy the application. Can anyone able to hear me?
Now,
Hello.
now we can hear you, but we lost you in between. Yeah.
Where you people lost? What
Talk.
place?
Can you please share your screen? Maybe we can tell you about it where we lost.
Oh, okay, 1 second. My screen got disabled. 1 second, 1 second. Let me contact them. Did we enter into Kubernetes?
Yes, yes. That pods one also has completed. Auto scaling has completed as well. Just after that, only something I discussed.
Sure. Let me contact them. They'll enable my screen share. Actually, I'm unable to share. Yeah, please enable my screen share. Actually, I'm unable to share. It has been stopped in the middle. My screen sharing is stopped in the middle. Please, can you please enable? Okay, yeah. Yeah. Now, can you see my screen?
Yes.
Okay. Where we have where you people lost at the
Practical use cases, load balancer has done. Yes, that has done. Commands and arguments that we discussed. Yeah.
Okay. Yeah. See, up to here we discussed, right? So now what are namespaces? Okay. What are namespaces? See, if you lost me one more time, please put that message in chat so that I'll be checking that. Okay. Sorry for that actually. So yeah. So yeah, explanation of namespaces. Actually, what are namespaces in Kubernetes means? Okay, what are namespaces in Kubernetes means? So it's isolation of your application. Suppose you will be deploying microservices in the Kubernetes cluster, right? So application payment related applications you will be deploying in the payments namespace. Okay, like cart related applications you'll be deploying in the cart namespace. So isolation of your application between the namespaces. Some people in the industry, what they does is to save the cost for their for their organization. What they does, they deploy their development environment, production environment, staging environment, and all the environments in one Kubernetes cluster, but in different namespaces actually. So such kind of organizations also there, but yeah, mostly they will not that is a high risk, because if one Kubernetes cluster has been happened, like is if that if for that Kubernetes cluster, if anything happened, entire application, all our system will be down. Okay, development environment will be down, production environment will be down, and staging environment will be down. So all the things will be down if you deploy all the environments in single Kubernetes cluster actually. Okay, that's the thing. Okay, practical examples and use cases and scheduling. Okay, introduction to scheduling in Kubernetes. Okay, introduction to scheduling in Kubernetes. What is scheduling? Okay, when you deploy, see, there are different servers in the Kubernetes clusters. So what is Kubernetes cluster? First, it's a combination of servers. Okay, suppose you have 3 servers in the Kubernetes cluster. It's a combination of, as it's a combination of servers, you have 3 servers in Kubernetes cluster. Okay, now so you deployed one application into the Kubernetes cluster. On which server your application will be deployed to, on which server your application will be deployed to, based on some conditions, based on some resources, and based on some things, you can force your application to deploy on the server number 1 only. You can force your application to deploy on the server number 2 only, or you can force your application to deploy on the any of the server in 2 and 3. Okay, such kind of conditions we are going to see as part of scheduling actually. Explanation of how Kubernetes schedules the pods and nodes, how the Kubernetes will schedule schedule means deploy the pods, your applications on the servers actually, that we are going to see. Manual scheduling of workloads with the help of node name. You can manually schedule your applications, you can manually deploy your applications. Like you have decided to deploy your application on node number 1, that means server number 1 only. You will use something called node name to deploy your applications on the server number 1 only. So that application will be deployed on your server number 1 only. So that's the thing. Okay, scheduling the applications using labels and selectors. Okay, using labels and selector. What are these labels and what are these selectors? Also we are going to see how we'll deploy the applications in scheduling, how we can schedule the applications on the Kubernetes cluster with the help of labels and selectors, that we are going to see. Scheduling using taints and tolerations. We have 2 types of nodes in the Kubernetes cluster: master node and worker node. What are nodes? Servers. It's just a servers. Okay, master server and the worker servers. Okay, master servers is required to handle entire Kubernetes cluster. Okay, master servers are required to handle entire Kubernetes cluster, but worker servers are used to handle our applications. It is for us to deploy the applications on the worker servers actually. Now, why our applications can't be deployed to the master server? Why it cannot be deployed? Such kind of things we will understand using taints and tolerations. Okay, so scheduling using node affinity. Okay, what is node affinity? What's the difference between taints and tolerations and node affinity? Okay, that's we are going to understanding the difference between taints and tolerations and node affinity. Understanding pod affinity and anti-affinity and difference. Okay, what is pod affinity and what is pod anti-affinity, and what the difference between pod affinity and pod anti-affinity? So such kind of things we are going to see. Practical examples and use cases of scheduling and security. Like these are the different things that we are going to see in scheduling. Okay, now in the security, what we'll be understanding is how to secure your Kubernetes cluster. Okay, if you are a developer, see, suppose the organization contains many teams. Okay, developers, testers, admins. Okay, DevOps people and operations team. So IT team. So something. These are the different teams that will contain in an organization, right? As you people know already, and each and every team should not have full access to your Kubernetes clusters. They should have only limited access. Okay, they should have only limited access. Developers should be able to only view their applications in the Kubernetes cluster. Okay, testers should be able to only test their applications on the Kubernetes cluster. Okay, admins should be having full access because they are used to maintain, they will be maintaining the Kubernetes clusters, and DevOps will be DevOps people also will be having the full access. Okay, to deploy the applications on the Kubernetes cluster and perform debugging and such kind of things. Suppose, see, such kind of access related security we are going to do in this security concepts. Okay, understanding service accounts. Suppose suppose your Jenkins CI/CD pipeline is there. Your Jenkins CI/CD pipeline want to deploy your application on the Kubernetes cluster. So for that, service account is required. If you create a service account, that will give something called JWT token. That token, if you give in the Jenkins, and that will be deploying, that Jenkins will be deploying the application on the Kubernetes cluster. So that is called service account we use for the user, for the human beings who can access the Kubernetes cluster. For those people, RBAC, role-based access control, security-based level, and for the applications, third-party applications like Argo CD, like Jenkins, like Flux CD, which will be connected to the Kubernetes cluster, they require service accounts. Okay, for the third-party applications, service accounts are required. For the human beings, in order to access the clusters, RBAC, role-based access controls are required. So that's the role-based control we are going to see. How we are going to see roles. What are roles in Kubernetes? Role bindings, a cluster role binding. What is the difference between roles and role binding? Cluster role and cluster role bindings. Okay, stat pod. What are static pods? Without any master node as well, you can run your applications on the Kubernetes clusters with the help of static pods actually. So what are static pods? We will be deploying, like we will be seeing one application to deploy as a static pod. So that we are going to see anyway. Okay, explanation of .cube config file. What is .cube config file? How it is structured, and why? Because of this .cube config file only, from your local machine, you will be able to communicate with Kubernetes cluster that is present in the AWS account or Azure account or the GCP account. Okay, so what is this .cube config file? How to look at it, and what are the different things that are there in it. So such kind of things we are going to see, and practical examples of and use case of security, all the things we are going to see in a practical manner. And networking, in the networking concepts, introduction to networking in Kubernetes. What are different types of what is a networking in Kubernetes? What is an ingress? Okay, suppose your applications may contain different APIs. Okay, your application may contain different APIs. Because of this APIs, because of this ingress, you need to forward the traffic. Suppose if your user sends the request for /test API, you need to forward /test API to particular application. If the user is sending the request for /demo API, okay, that request has to send to another application. So such kind of path-based routing, okay, such kind of path-based routing we are going to see as part of ingress. Okay, what is ingress? What is its significance? What are different available ingress controllers? Okay, what are different available ingress controllers? So there are many controllers, ingress controllers are available in the market. So like GluE, STO, Nginx, Kong, okay, such kind of API 6, something like that. Okay, there are different ingress controllers are available in the market. We are going to see two types of ingress controllers. One is Nginx ingress controller and other one is Kong ingress controller, and we are going to do the projects actually, practical examples of Nginx ingress controller and Kong ingress controllers, and understanding network policies and use cases. Okay, what are the network policies available and why we use the network policies and their use cases we are going to see. Service internal traffic policy. Okay, we are going to see this, and practical examples and use cases of networking. Okay, everything. Okay, everything will be in practical and in an understandable and diagrammatic manner. Okay, so backup and restore, how you can perform backup of the Kubernetes resources actually. So there are something called jobs and cron jobs, which are responsible for backing up the Kubernetes data that is generated by the applications. So how we can back up that, with the help of jobs and cron jobs we are going to see, and ways to back up Kubernetes resources. Okay, what are the different ways that are available to back Kubernetes resources? Rolling updates and rollbacks. Okay, rolling updates and rollbacks. Suppose you deployed one application and that is perfectly working, and tomorrow you added one more feature to that application, again deployed that application to the Kubernetes cluster. Okay, but this time, second time, your application is giving some issues, but immediately user should not affect the the users who are accessing that application should not affect, right? So you will be rolling back to the previous version of your application. How to do that? Rolling updates and rollbacks without any downtime. How can you roll back and how can you do rolling updates? So such kind of things you are going to see. Okay, monitoring and troubleshooting in Kubernetes. Okay, introduction to logging and monitoring. How to look into the logs in the Kubernetes clusters, in the like of the applications actually. Because of these logs only, you will be able to find the problem, where the problem occurs, and what is the reason why this problem has been occurred. You will be able to find the such kind of thing using logging. Okay, what's the difference between logging and monitoring? Okay, logging is to check the logs. Okay, monitoring is to check the metrics, like how much amount of CPU is used by this pod, how much amount of memory is used by this pod, how many number of requests are coming to this pod, how many number of like 200 responses are going out of this pods, how many number of 400 responses are going out of this pod. So such kind of monitoring, such kind of things will be coming under monitoring. We are going to deploy like metric server into the Kubernetes cluster in order to like visualize how much amount of CPU and how much amount of memory that are consumed in the Kubernetes cluster by the workloads actually. So that we are going to see in the monitoring. Okay, different issues that occur in Kubernetes cluster. See, before like if you know prior itself what are the different issues that will occur in the Kubernetes cluster and how to solve those issues, so it will be very clear for you. Okay, why this problem, if when you are working also, if that same problem occurs, you will be easily finding the reason why this problem has been occurred and how to solve this problem. Okay, so such kind of knowledge you will be getting here. Okay, such kind of things. Okay, so that's the thing, different issues that may occur in Kubernetes cluster. If any issues that are automatically occurred, that are also we are going to solve. If we are going to create some issues and we are going to understand why that issue happened, and we are going to solve that issue, so that it will be very clear for you. You will be understanding how, why the issue, reason for that issue actually. So that's the thing. Okay, now there's a visiting logs and describing application to debug applications. So to debug, I already told you, to debug any application, you need to visit logs and you need to visit events. Okay, you need to understand first whether that problem is been occurred with the help with respect to application, or whether the problem is with respect to Kubernetes cluster. There may be two types of problems. Your application may be a problem and the Kubernetes cluster may be a problem. Okay, you need to understand that first. Okay, whether that problem is of the Kubernetes one or whether the problem will be of the application one. You will be understanding that looking at the logs and describing the applications, looking at the events. Okay, such kind of things will be there. Okay, so understanding the problems and its significance, I already tell you. Monitoring the Kubernetes cluster with Kubernetes dashboard. We are going to deploy Kubernetes dashboard in the Kubernetes cluster. So this why this dashboard is required. Okay, why this dashboard is required? To visualize our workloads, what are different pods running. Okay, what are the different deployment consists of different, suppose deployment consists of 10 pods. Okay, out of 10 pods, how many pods are actually running, how many pods are in failed process, failed status, how many pods are in with the problem state. So such kind of visualization you can perform using Kubernetes dashboard. Okay, other tools that we are going to see is Helm. Okay, what is Helm? Helm is a package manager to deploy the applications to the Kubernetes cluster. So that we are going to see installing Helm and working with it. Command used to deploy the Helm and Helm with Helm and their explanation, and working with Helm explanation and folder structure. What is a folder structure that are there with Helm? How to use functions, how to use templates, how to use values.yaml, chart.yaml. Okay, it's like what is helper.txt file. Okay, what is a different folder structure we are going to see, and how to use if conditions, loops. Okay, in YAML, like in HTML, like in Helm charts. Okay, so that's a different things we are going to see. Okay, K9s tool is more is been evolved in the industry. It has been more popular. What is K9s tool and what is it used for? How to visualize this also for visualization purpose, but it's a client side tool. Kubernetes dashboard is a server side tool. If the server is down, your Kubernetes dashboard application will also be down. Okay, but K9s tool is a client side tool. Okay, you will be installing K9s tool in your local machine so that you can visualize that Kubernetes workloads in the K9s tool. Okay, K9s tool is a client side tool. Okay, now to manage tool to manage multiple EKS clusters. Okay, so Argo CD to automate the deployments to Kubernetes cluster. What is Argo CD first? Argo CD is a continuous deployment. Suppose if you change the version of your application, that Argo CD will be automatically detecting that change in your GitHub, and that will be automatically deploying that your application to the Kubernetes cluster without you manually interacting with the Kubernetes cluster, without you manually deploying that application to the Kubernetes cluster. Argo CD will does that for you. That will be automatic process that we go with the Argo CD. Argo CD is a popular tool that has been evolved in the industry, which is integrated with the Kubernetes and which is using the Kubernetes for automatic deployment of your workloads to the Kubernetes clusters actually. So projects, okay, what are the different projects? So we are going to see the projects on combination of Docker, Kubernetes. Okay, we are going to see the different projects on Docker, Kubernetes, K9s, Argo CD. Okay, summary about the thing. Summary at last, we are going to see the summarize everything. Okay, what is this importance of Docker and Kubernetes? Okay, this Docker and Kubernetes will be used by top companies and very medium level companies and startups are highly interested in giving the jobs to the Kubernetes and Docker people. For example, Walmart uses Kubernetes and Docker to deploy the applications. Okay, Adobe uses Docker and Kubernetes. Okay, like Qualcomm uses that. Okay, so many companies uses the Docker and Kubernetes to deploy their applications, to deploy their resources, to deploy their applications, to deploy their microservices in secure and automated way. Okay, automated way to their Kubernetes clusters actually. Finally, we are going to summarize everything what we have learned, and that's a course content. Say huge, and you will be getting more knowledge in this course. Yeah, if you have any questions, it's open for the questions now.
Hi, sir. Good morning.
Good morning.
Yeah, I joined a bit late. I don't know whether you have discussed this one or not. My question is, how many hours of class this is in terms of content in daily basis and overall also?
Yeah, actually, it's weekly, as you know, it's a weekend batch. It for every Saturday 2 hours and Sunday 2 hours, something like that. Okay, 1.5 to 2 hours and doubt clearing sessions, something like that. Okay, that's every overall it will be 40 to 40 hours. I mean to say.
So total every week it's 4 hours and
Yes.
so 5 weeks, 20 hours, right?
Yeah, 20 hours, but I mean to say some of the extendable things will be also happening. Suppose if we are discussing some concept in the Kubernetes cluster, but the time got finished, right? We cannot stop that concept in the middle. Such kind of sometimes that will be extendable things actually. So
Your voice is breaking. Hello.
my voice is breaking now. Can you hear me?
Yeah, it's clear now. So is it a 20 hours or 40 hours? I mean, 20 hours can be extended to, as per your scenario, it can be extended maximum to 22 or 23 or 25 max to max. How can it be double? So what's the consist of hours? I mean, you have any idea?
No, it's a max is 40 hours. You see, actually the max is 40 hours because the course content is huge. Okay, I mean to say the course content is huge. because of that, okay, what we does is we tell the 40 hours, something like that, and it may be very less also. And like suppose we are discussing any concept, we are discussing the Kubernetes storage, but if when discussing the Kubernetes storage in particular class, if the time got completed, now we will not stopping at that moment, right? If the time got completed, we cannot stop that particular concept in the middle, and we will be discussing further for 30 minutes, something like that. So such kind of things will be happening, and some extra, like not only 5 weekends, if the time is not enough, we are going to extend that to 6 weekends as well. So overall, I am saying such kind of things.
Okay. And okay, so in terms of the practice, so is there any environment will be given or direct AWS EKS will be covered?
So I will be showing you 3 different ways. Okay, one is kubeadm way. There is no environment will be given with the DurgaSoft by the DurgaSoft. Okay, I'll be showing you the 3 different ways of Kubernetes clusters. Okay, one is kubeadm way, minikube way, and EKS way. Okay, you can decide in which environment you can do your labs. Okay, that's the thing.
Okay, so today is there any will be class or only syllabus discussion only?
No, today class will be there actually. Its time did not complete.
Okay, okay. Fine. And any running notes, everything will be given?
Yes, running notes will be given, and what are the different manifests that we are using, that will be uploaded into your drive, and you will be accessing the drive, and you can download your manifest file from there, and you can practice your labs.
Okay, fine. And what is the last day of your demo? Tomorrow?
Yeah, tomorrow, and like I can say tomorrow, but I'll talk to DurgaSoft people. If the response is good, I can extend that to next week also.
Okay. So 5 weeks from the start of your paid members batch or 5 weeks from today?
No, 5 weeks from today.
Okay. Thank you. I'm done with my question.
Anyone have any other questions, please? You can ask anyone.
Yeah, hi Shiva. It's Abhishek actually.
Okay.
Yeah, am I audible?
Yes, you are audible.
Yeah, so I just want to know like what exactly the RAM size will be required to do the application for Docker in Kubernetes?
See, that entirely depends on the number of applications that you deploy on the Kubernetes clusters. Actually, minimum you require is 4 GB. I mean to say minimum require is 4 GB. But after that 4 GB, how many number of applications that you deploy on the clusters or the Docker, that depends on your deployment of applications. How much amount of your application consumes? Suppose you deployed your application that may consume 1 GB. Okay, but some other applications will be consumed 2 GB. That entirely depends on your application. So you need your application, like your Docker or Kubernetes, we should have that much amount of resources, CPU and RAM, to handle that application, actually, to know how to run that application. So if the Docker and Kubernetes does not have that much amount of CPU and that much amount of RAM, your application will not be deployed. That will be in a pending state in the Kubernetes clusters, actually. So that entirely depends on your workloads. That means your applications.
So you are saying that minimum that the RAM requirement will be of 4 GB, right?
Yes.
Okay, and one more thing is that so being an backend developer, so how do you recommend to go for Docker and Kubernetes? Whether the entire syllabus will be based on as a developer point of view or a admin point of view?
No, we have put our mind in 2 people, developers and the admins. Okay, I told you in the course syllabus also, because developers, or nowadays developer also should know, like people are expecting, industries expecting the developers to also know the Kubernetes and the Docker as well, because you need to understand how the applications deployed in the Kubernetes cluster, how they will be handled in the Kubernetes, how to write the Docker files, and how to write the multi-stage Docker builds to increase the security and decrease the image size. So such kind of things also you people know. You people should be able to know. So it is, this syllabus is created in the perspective of developers, in perspective of admins. Okay, so everything will be covered like that.
So after is there any certification as a developer we can go for Docker in Kubernetes?
Yes, you go in Kubernetes, you can go for CKID certification, that is Certified Kubernetes Developer Associate. You can go with that, and you can also go with the Docker.
And what exactly are the AWS services will be used in order to implement those Docker in Kubernetes?
Yes, we are going to use EC2 machines. We are going to use EKS clusters. We are going to use cloud formation. When you create EKS cluster, there will be a cloud formation stack will be automatically created. But yeah, we will not use entirely that one. We will not go deep diving in that, but that will be created. I mean to say, like cloud formation stack, and we are going to use the load balancers, and auto scaling groups will be created. So such kind of services, and these are the main services that we are going to use. Yes.
So those services which are
And the VPC.
yeah. So those services which are, let's say, unknown to us, like, do we need to have any sort of video access or any sort of material based on that services actually?
No, that services belongs to AWS. No need to understand, and that will be you will not be creating that one. Okay, if you deploy the Kubernetes cluster EKS way, that will be automatically created internally with the help of cloud formation stack. That like cluster config file does for you. You don't need to understand the services. You need to understand the Kubernetes parts only. What are the different Kubernetes things, and that is related to AWS. You no need of understanding in this course for that. Okay.
Okay, so you mean to say that we don't need to have any sort of knowledge in AWS services?
Yes, I mean to say that. Okay, because you may be from GCP or you may be from Azure. Okay, you can install this Kubernetes cluster there also. Okay, so it does not mean that you should know the Azure or you should know the GCP, but yeah, you should know the Kubernetes. You can also install the Minikube in your local machine also. Okay, so and you can use the Minikube on the one of the Kubernetes server. So you can install something like that. Okay, if suppose you don't want to use load balancer, you don't want to use auto scaling, you don't want to use cloud formation stack, if you don't want to use all these services, if you want to use like KubeADM way of creating cluster, you can only use EC2 machines, and you can create a Kubernetes cluster there. You no need of understanding the different concepts. So in AWS, you need to understand that Kubernetes concepts, and you need to understand the Docker concepts. If any problems appear with that AWS related services, I'll be telling you here is a problem occurred, like you will be understanding that also. Okay.
No, actually, what I was meant to say that, let's say, VPC is one of the services at AWS, right? So if you are using that VPC, people need to understand that what exactly the VPC is doing. So if it will be a new concept for anyone, so do we have any sort of metric for that particular service? So that's what I'm asking.
No. This course does not does not include the GCP VPC. So because that's a different concepts in AWS course that will be coming under, because VPC, EC2, what are all these things? These are AWS services. This course does not contain this.
Okay.
Yeah.
So, it's you said that it will be a 5 weekend, so it may prolong to 6 to 8 weekends also, right?
Yes, 6 to 7, not 8, maximum 7, 6, 7, something like that. Yes.
Sir, what is the deadline? 5 weeks, 6 weeks, or 7 weeks? I'm not getting any construct answer from your end.
Yes, minimum 5 weeks. It can extendable. It can extendable up to 8 weeks. So 5 to 8 in the middle. That's it.
So if you can ask you in other way, you probably have taken the batch for the earlier batch, like what exactly the timeline for them actually? It's so
Exactly, batch timings will be same time, 8 to 10 a.m. morning, and
no, you didn't get actually. So what I'm
your
trying
previous
to,
batch, he is referring as per your previous batch
the previous
experience.
batch
how
only.
many-
Yes,
Yeah.
previous batch only, 8 a.m. to 10 a.m. Okay, so first batch we completed it 6 weeks, and second batch, based on their understanding and based on their questions in the classes, we completed 7 weeks. So that entirely depends on the situation that we are handling at the current moment. Okay, so I cannot tell for you like it will be complete. I can tell minimum and maximum. So in that point that will be there, because it entirely depends on the questions you ask, and it entirely depends on the time we spent, and it entirely depends on the different things, different aspects actually. So such kind of things will be there. Okay, so minimum and maximum, I can say minimum is 5 weeks, and the maximum is 8 weeks. It will not take 8 weeks, more than 8 weeks. Like it will complete maximum, I can say 7 weeks only. Okay.
Okay, okay, thanks. Yeah.
Yes, you are Ranjit this side.
Yeah.
Over the week, you are going to support us in terms of if we are doing hands dirty and trying to do with Dockers and Kubernetes, and over the week you will support via email, or is there any
Yeah,
channel?
we are going to create a Telegram group. Okay, you can
Okay.
paste your questions there, and anyone who know the answer, if that answer is wrong also,
Yeah.
can put that your answer there. It's not a wrong thing. Okay, if yeah, we will be creating Telegram group there. No problem.
Okay. Okay. Thank you.
Hi, Shiva sir. I have two questions over here.
Yeah.
My name is Prashant. So actually, I'm a fresher. Totally, I'm a fresher to Docker and Kubernetes. I don't know anything.
Okay.
So I'd like to know one thing, that shall we have, I mean, I need to learn some other technology for proceeding of Docker Kubernetes, or that is fine, that if I won't know anything, like as you told that AWS must require for something easy to compute, kind of that. So if I don't know that all things, so is it fine for me to continue with Docker and Kubernetes?
Yes, you will be able to learn Docker and Kubernetes, actually concepts in Docker and Kubernetes, but you will not be able to learn EC2 machines and EC2 like whatever load balancers and whatever the like auto scaling groups. Those are entirely related to AWS course actually. So it's not required, I mean to say, in my point of view, it's not required to understand the AWS services actually. So you can, without understanding the AWS services also, you can understand the workloads in Kubernetes and different objects that are there in with Kubernetes, why we use those objects. You can understand that very well without using that. That's a very internal thing. If you understand, you see, if you understand the AWS workloads also, that is really good. I'll not against that, but because if you like in this course, it is not taught actually. It's not included the VPC, auto scaling, and load balancing. That is not included. This entirely course related to Docker and Kubernetes. Okay, we will be understanding only Docker and Kubernetes, and you will be understanding really good. Okay, so that's the thing.
Okay.
You no need of understanding like what are the different services like VPC, cloud formation, or the EKS. Those things no need of understanding. You can, without understanding also, you can understand this course very well.
Okay, and I have one question here. So, can you please, is this possible to add, I mean, one more point in the content towards of the Jenkins configuration? I mean, how to do configuration of Docker Kubernetes in Jenkins? I mean, not totally, we are, I mean, I'm hunting to know about the Jenkins, but only a very small part, that once this course got completed, Docker and Kubernetes, then how we can configure the same in Jenkins. So can it be possible to add that one in our content?
See, if I add content, the time will be more. Yeah, I cannot decide on this concept, because there is one of the course running in the weekdays batch. Okay, it's from 8 a.m. to 9 a.m. It's Jenkins, Docker, and Kubernetes, all the three. So I need to discuss this point with the DURGASOFT people. They need to accept that actually. So it's, I cannot tell, I cannot comment as of now, because that's the thing. That's we planned actually Docker and Kubernetes. But I'll be telling you how the industry uses Jenkins to deploy the their applications with automated way with the help of Kubernetes clusters actually. I can tell
Yeah,
that.
that would
Okay,
be
but
very much appreciated. Yeah.
deeply, not deeply. Okay.
Okay, not, we are also not, I'm not looking for deeply. Only like you have to show us that how to configure the Docker Kubernetes in Jenkins instead of putting our manual intervention. Then how we can make it automate. That is the main motto to know.
Sure, I can do that. I can do that for you, no problem.
Sir, this course is for who's all? I mean, is this for a developer or a DevOps person? And this is point number one. Point number two is, as Durga said, is having a PDF note. So whenever you go to Amipet, you will be getting Durga's or Java notes. It is available over there, the PDF or the hard copy. So in terms of that, do you have
Yes.
anything so that we don't have to take any running notes after your class? If we just go through that one, that is good enough for us. These two questions.
Yeah, actually, yes, yes. The PDF notes you talked about is we have for each and every concept, not one, like we have one file for the each and every concept. We all the files is not put together for each and every concept. I'll be sharing you that file. You can use that file and you can understand the things there. That's the thing I can understand. What's the other question you asked?
This course is for a developer or a DevOps engineer.
This course is designed for keeping in mind that developers and as well as DevOps or the admins or everyone, this course is designed like that. Okay, it's not for only for developers, it's not for only for DevOps people. You can see Docker Compose we have put it here because this Docker Compose we put here, but this is not used by mostly DevOps people. This is used by developers only. So it is designed in such a way that both developers and the DevOps or admins will be profitable. Okay, something like that. Okay.
Okay. When we'll start today?
Yes, we will be starting in few minutes
And by
because
10 we'll be wrap up every day, right?
yes, by 10 we'll be wrapping every day, every weekend. Yes, yes.
But sir, 5 weeks, 2 hours, so 20 hours, this much of syllabus, I believe it's too short, 20 hours, right?
That's what I am
I
saying.
mean, other organizations are covering 40 hours minimum, 40 to 45 hours
Yes,
to
yes,
cover
that's
all
what
these
I
things.
see. We will not skip each and every concept. We'll definitely do each and every in a practical manner. Will not do not raise that question. Will not skip anything. We'll be doing each and every in a practical manner. You can also contact with my previous students. They'll also tell the same, and we will be discussing each and everything in the course, because that is why I'm saying its minimum is 20, maximum it go to 80, like it's 40, something like that. Okay, that's the 8 weeks, I mean to say.
So what is official, 5 weeks or 8 weeks?
That's what I cannot comment. See, I have completed 2 batches, weekend batches. One completed for them also. I have told you, I have told the 5 weeks, but that completed first batch is 6 weeks and second batch went completed with 7 weeks. That entirely depends on the questions or the concepts we discussed, the way of the diagrammatic part and the time we spent. Such
Got
kind
it.
of, it entirely depends on the thing, but yeah, I am telling the minimum is 5 and the maximum is 8. So between this, anything may happen.
Okay.
Yeah, Shiva, I'm okay with extending the weekends, but just to make sure everything will be covered in a normal speed, right?
Yeah, that is the main thing.
Yes, everything, do not rise that. Everything will be covered in a minimum understandable manner, and you can easily get the concepts and easily get the concepts in how I'll explain, like cutting the cake and putting in your mouth, something like that. Okay, so it will be in that manner. Okay, you like it, the practicals will be in that manner. So suppose if I use this keyword, if I use something called image keyword, why that keyword we are using there, such kind of explanation will be there.
Okay.
Okay,
Yeah,
so
then it's fine for me. It's no, just make sure normal speed. Sometimes 2x will, I think, some of for me, I think it will not work because not much familiar about this. So it's a normal speed works for me. That's, I think, others for others as well.
sure, I will keep in mind everyone in the class, and I'll continue with that. Okay, so yeah, that's the thing.
Yeah, okay, Shiva.
Anyone have any questions, or shall I continue? Please ask your questions here and we'll continue together. Anyone has any questions, please go ahead.
No questions about the, no questions on this course content. Apart
Mhm.
from that, about that payment, what has mentioned about the PhonePe and Google Pay, I just asked one question that which name that has registered. For me, it's showing N Razia, but not sure. So just reply me that answer would be helpful for me to pay the amount.
Yes, this entirely the payment handles entirely with the DurgaSoft. My responsibility is the
Okay.
course and the technical documents and the doubts. Every other administration things will be handled by the DurgaSoft. I don't know to which account you need to pay, but you
Okay.
need to contact DurgaSoft. They are also given the contact numbers. You please contact them, and you will be able to pay. They will be able to guide you. Okay.
Okay, sure then. That's all.
Yeah. Clear. Everything is clear.
Yes, sir.
Yeah, thanks for that. Yeah, now what we are going to do is how industry uses this Docker and Kubernetes in their environments, in their development or staging or demo or the production environments that we are going to see now. Okay, you need to understand that first. Okay, before using Docker and Kubernetes, why we need to use the Docker and Kubernetes first? Okay, why we need to use, what is the requirement that came with the industry to use Docker and Kubernetes? Okay, you need to understand how the Docker and Kubernetes used in the industry to deploy their applications on the Kubernetes clusters or on the servers or the virtual machines. Servers, virtual machines, Kubernetes cluster, everything is same as of now. As of now, you think of same, but they are different when we deep dive in the course. Okay, now let's go to the diagram first. Okay, let me go you through the diagram. Okay, so here is the developer who developed an application. Whether it is any application, whether it is a Spring Boot application, whether it is a .NET application, whether it is a Python application. Okay, let's take an example of Spring Boot application. This developer, actually I'm drawing only one developer. There will be a group of developers, as you already know. Okay, now this developer will be pushing that code which he developed into version control system. Okay, what is version control system? It's a like GitHub, you know, right? GitHub, Bitbucket, GitLab, okay, something like that. Okay, any version control system that is available with their organization. VCS, let me put VCS, that is version control system. Okay, that is VCS. Now this developer will push his code to the VCS. Okay, he will write code as well as unit test cases, whatever the framework he uses. Well, that's none of our business. Okay, he will write the code and it will be pushed into the GitHub or VCS, version control system. Now this code, and there are servers. Let's understand there are servers. Okay, this is a server where we need to deploy the applications. Okay, this is a server. Okay, let me put here server. Okay, okay, this is a server where we need to deploy the application. Okay, now this code which is developed by the developer cannot directly put on the server. It cannot directly put on the server. It will not actually work if you put this code on the server. Actually, how this code is internally converted to Docker image, how we deploy to the server, we are going to see now. Okay, this code which is developed by the developer will be converted as artifact. We call it as something called artifact. Okay, let me draw a diagram here. What is an artifact? Suppose artifacts is a set of files where that files contain our application. Suppose zip file, you will be creating a zip file. What that zip file contains? Zip file contains all the files that is created as zip file, which you can send to your other user actually. So in the same way, this application which the developed by the developer is converted as artifact. In that artifact, what it contains, that artifact contains our application code. Our application does not contain only one file. Our application will be split into multiple files and they are combined together and formed as an artifact, that artifact is this one. So in case of, as we are discussing, as we are thinking about Java, this artifact name, what is the extension that we will be having with artifact is .jar file. Okay, in case of our normal files, we'll be creating .zip file, right? In the case of Java application, we'll be creating jar file. Okay, that's the difference. So that's it. Okay, now this is jar file. Okay, let's think this is as artifact. Okay, now how we convert this application to artifact is using Maven. Okay, we will include Maven. Actually, you can see what are the different concepts comes under, right? But Maven I did not put in the syllabus, but Maven will also be there to convert this code into artifact. Okay, that's where the time consumes actually. So let me put Maven. Actually, see, this is the Maven that we will include. This Maven is a build tool. What Maven is a build tool that is used to convert our application into artifact. Maven. So there are different build tools are available in the market, like Gradle, Maven, Ant. Okay, so this is a Maven. This is a tool to convert this our application into artifact. Okay, this is the tool that is will be converting our application to artifact. This artifact, this be like with the help of this artifact, we will be writing something called Docker file. We will be writing something called Docker file. Okay, why will be writing something called Docker file? Because we need to convert this application as Docker image. So like just bear with me, because the Docker file and Docker images and Docker containers are it's a new things, maybe new things for you. We'll be going through the course, through the course, that one, what are the different keywords. Okay, so that's the thing. So this artifact we will be including this artifact into this Docker file. We'll be writing something called Docker file. Okay, how we'll write, we also go through. Okay, now this is the Docker file. Docker file. Okay, this is a Docker file. Okay, this Docker file will be converted as Docker image. Okay, this Docker file will be converted as Docker image. This is Docker image. Let me consider Docker image. Okay, this is a Docker image that is converted from this Docker file. Let me take like this. Okay, now this Docker image, for the version controlling purpose, you will be pushing this Docker image. You need to have some storage to store this Docker image somewhere. Okay, for that storage, we will be pushing this Docker image to something called ECR, like not ECR. There are two types of Docker registries actually that we'll be going through the course. One is private Docker registries and public Docker registry. Why the Docker registries are required? To store these Docker images. Okay, now to store these Docker images. So private registries means only you people who has the access only can able to access the Docker images which are present in the private registry. But public registry, anyone in the world can able to access that your Docker image. Okay, that's a public registry. As of now, just think this is a registry where we store the Docker images of our application. Suppose what this Docker image contains, our application, it contains from the artifact. We included these artifacts in the Docker file. From this Docker file, we created a Docker image. What this Docker image contains? Our actual artifact. That means what is the artifact? Our application code. Okay, that means the Docker image contains our application code. Okay, this application code, like this Docker image, will be pushed to Docker registry. This is called Docker registry. One second. This is called Docker registry. Okay, Docker registry. This is called Docker registry, where we will be storing our Docker images. Okay, we will be storing our Docker images. From this Docker registry, industry will be deploying their applications on the servers. Actually, on the servers. Okay, on the servers. Okay, they will deploy this image with the help, like on which is stored in the Docker registry on the server actually. So this is how industry follows to deploy their applications on the servers, whether it is the server belongs to production, or this server belongs to development environment, this server belongs to stage environment or pre-prod, something like that. Okay, so in this manner, the applications will be deployed to the servers in the industry. Okay, now where the Jenkins comes into picture in this case, Jenkins is a way to automate all these things. All the things we deploying to the like converting is artifact and creating Docker file and pushing the Docker, converting as Docker image, and like from the Docker image to Docker registry, all these things all this process will be automated by Jenkins pipeline in the industry. But as we are not looking into Jenkins, we will be seeing this pipeline in the, like, the ultimate prototype will be this one. Okay, creating artifact, that is a jar file, using Maven, and from the artifact will be including in the Docker file, and Docker file will be converted as Docker image will be pushed to Docker registry, from the Docker registry we will be deploying our Docker image to the servers actually. So that's the ultimate prototype. There are different internal things involved that we discussed in the course, but this is the ultimate prototype of what we are discussing. Okay, so that's the thing. Any questions you have with this architecture? Any questions anyone has with this architecture?
Yeah, I'm having one doubt actually. It's like, what was the need of Docker actually? Prior to that, what was the issue that we now is going for the Docker deployment process?
This is, we will be going through that in the next thing. Okay, what is the need of going to Docker and what is the need of going to Kubernetes? That is there. Okay, yeah.
No, I mean to say that what exactly the need of Docker actually, because prior to that Docker was not there, so still that application get deployed at the server. Like, what was the issue actually in that?
Yes, we will going through the course. Okay, just we started, this is a prototype, that's it, that is there in the course. I'm saying just next is that only. Okay, why, what's the need of going to Docker? We first, before understanding the Docker, you need to understand the physical servers. What is it, what is the disadvantages of using physical servers? You need to understand why we need to went to virtualization, because of the disadvantages with the physical servers, and what are the disadvantages with the virtualization you have, why we went to Docker. You need to understand that manner so that it will be very clear. That is there in the course. That is the next point we are going to discuss. This is a prototype how we will use in the industry. What you discussed is the next point which we are going to discuss. Okay, what is the use of going to Docker? Okay, yeah. Any questions anyone has with this prototype, with this?
On this one and going forward also, sir, whenever we will be, taking any kind of example in terms of the application, so which kind of application will be taking as an example? This is a Java, right?
Yes, this is a Java application. I'm going to take the Python applications as well. Okay, Python and Java applications I'm going to take. But if the requirement is there, if you people, if anyone are from the
No, I'm a
Node.js
pure Java guy. That's why I'm asking. Java is
okay,
good for me.
Spring Boot application.
Yeah,
Definitely, we are
Java
going to
Spring
see
Boot.
the,
Java Spring Boot it will be like a very good scenario for me to understand,
yes, you are right. We will be converting that Java applications into Docker images in the course. Yes.
Okay, fine.
Anyone have any questions, please? You can ask. Anyone have any questions with this? Anyone have any questions? Okay, if no questions, this is a prototype actually. Now let's go to the things, actual things. Okay, now we completed this tutor introduction, general introduction, and course introduction. Now you need to understand these things actually first. Okay, you need to understand these things actually first. What is DevOps? What is DevOps actually? DevOps is a combination of development as well as operations. Development in DevOps means it's not an application development, we call it as in DevOps. It's a developing scripts in order to automate the regular activities that we do. It may be the Python scripts, it may be the groovy scripts, it may be the different scripts, shell scripts, okay, that we develop, in order to automate the creation of the infrastructure, in order to automate the manual process that we do, that is the development we do in DevOps. But DevOps also, developers are like DevOps people also should be able to know some of the functionalities of the applications, like why the 400 error has been occurred, why the 403 error has been occurred, what is the STB like 503. 503 is server side internal server error. Why it is occurred? 503 occurred. That is server side issue. You need to handle that. You need to, that DevOps people should be able to know such kind of meaningful errors and such kind of application functionalities they need to understand. Okay, that comes under DevOps. And operations means maintaining the applications that are deployed on the servers and maintaining the server. Suppose security, releasing security patches, okay, regularly updating the versions of the application. Suppose today developer has developed 1.0 version of the application, he deployed that one, and tomorrow developer has been developed 2.0 of the application version of 2.0, and this DevOps will like operations team should deploy that 2.0 to the system, like servers actually. So that comes under operations development. In the DevOps there are two things, DevOps. DevOps, like dev means development, ops means operations. Dev means developing scripts in order to automate the manual process. Operations means maintaining the created infrastructure and maintaining the applications we deploy, regularly providing the security updates, something like that. Operations. What's an application? Application means it's a website. Okay, we have different applications in a browser, right? So like Redbus and Amazon, Flipkart, Mintra. So these are the different web applications that we have. That is an application, just a website. Okay. So what is SDLC? SDLC is a process that we follow in order to develop an application in the industry. Actually, SDLC is a process that we follow in order to develop an application like in the industry. Actually, these are the 6 phases of SDLC. Let me go quickly through this. Okay, there's a requirements phase. Okay, there's a requirements phase actually. So what this requirement phase contains? Okay, so first phase is called requirement phase. This requirement phase contains how many people are needed, what are the different things needed in order to develop this application, and all the requirements will be collected in this requirement phase actually. Now the design phase, next phase is design phase. There will be a complex system design. Okay, there are something called design patterns in developing applications. Okay, people will be following design patterns, or system design will be happening. UI UX designer will be there. They will be designing the application, and they'll be sending forward actually. So that design phase will be happening in this design. That design things will be happening in this design phase. Suppose for if you are a fresher, let me say you one example. Okay, suppose if you want to log in any website, right, you should be able to that will display the username and password to enter, right? So in the design phase they will decide where that username and password should be there on the screen, whether that should be on the top of the screen, or that should be on the bottom of the screen, or the left or the right or the middle. So they will be such kind of decisions will be happening in that design phase. That will be did by the UI UX designer that will be working in that design phase actually. So that's the design phase. Once the design is being completed, that design will be sent to the development people, and based on the design that is given by the design people, and developers will be developing their applications. Suppose that may be in any language that is suited to their application. It may be a Spring Boot, it may be a Python, or it may be a Django, or the Node.js, or the it may be any React, or any language they will take, and they will be developing the applications. Front end application will be developed in the React, and the backend application will be developing the Node.js and the Spring Boot. So development will be handled by the developers. They will be developing the applications based on the design they're given by the design people. So in the development phase, they will also write something called test cases. Okay, unit test cases they will write for their application. That is the responsibility of the developers that are there in the development phase. Okay, so they will follow some of the frameworks like JUnit, Mockito, PowerMock, such kind of thing they'll follow in order to write the test cases. That's none of our business. So they'll follow that. Okay. So next phase is the testing phase. In the testing phase, people will be testing their applications, whether it's a regression testing or performance testing, as stress testing. So any type of testing team will be there, and they'll be performing testing of the applications the developers has developed. They will also have something called test cases, and they'll be performing the testing on those applications developed by the developers. Actually, this is the testing phase, and deployment phase is important for us. This is where our Docker and Kubernetes comes into picture. Actually, so Docker and Kubernetes comes under deployment phase. Okay, deployment phase. Okay, so the way we deploy our applications on the Docker and Kubernetes with the help of Docker and Kubernetes comes under deployment phase. Okay, maintenance phase. Okay, maintenance phase is the maintaining of our applications which is deployed in the deployment phase, like regularly providing the security updates and regularly updating the applications with different versions depending on the development from the development team. So such kind of maintenance will be happening in the maintenance phase. Actually, our phase that we need to concentrate on is deployment phase, because the Docker and Kubernetes comes under this deployment phase only. This is the SDLC process that the industry follows. So there are different cycles, like agile is there are different processes are there, but as of now, let's discuss this. Okay, so this is where our Docker and Kubernetes comes into picture. Okay, now what is a server? Server is a way that is there to make our application accessible to the entire world. Actually, what we this based on this SDLC process, people will be developing the application. In order to everyone should be able to access that application, right? So in order to access it, in order to make available to everyone in the world, we need to place that application on the servers. Actually, that are servers. Actually, so there are different types of servers are available. So we will be going through that. Okay, now where does Docker and Kubernetes fits in SDLC process? That Docker and Kubernetes fits in deployment phase of SDLC process. Okay, now deploying applications on physical servers. Suppose we have previously in the previous times, we have something called physical servers. So people used to deploy their applications on the physical servers. Actually, so there are some disadvantages that we have if we deploy your applications on the physical servers. Okay, let's go through one by one. Okay, as part of diagram. Okay, now let's select everything and let me remove this and let me go here. Suppose this is the server, this is a physical server. Okay, this is a physical server where the people used to deploy in the previous times. Okay, now let me take this as physical server. This is a physical server that we have, and this physical server will be having some amount of CPU and some amount of RAM, right? So this physical server has 10 CPUs and 10 GB of RAM. Actually, let's think this physical server has 10 CPUs and 10 GB RAM. Okay, that it can run. Actually, that it has actually. And now we have deployed our application on the physical server. Okay, we have deployed our application on the physical server. This is app one. Okay, this is app one. Now perfectly okay, if we have deployed and everything is okay, and now we have some disadvantages. Okay, we have some disadvantages if we deploy the application on the physical servers. What are the disadvantages that we have? Let's go through one by one. Okay, now disadvantages of deploying applications on physical servers. Okay, Okay, there are the disadvantages that are there. Let's go through one by one. First disadvantage is, like, suppose my physical server has 10 CPUs and 10 GB memory, right? Now my application is using only one CPU and 1 GB memory. Okay, now what about remaining CPUs and remaining memory? Okay, like 9 CPUs are there and 9 GB memory is there. Okay, 9 GB memory is the remaining, right? So only one CPU and one GB memory has been used by my application. Then what about the remaining 9 CPUs and 9 GB memory? So there is a resource wastage. What is a resource? Resource is something called CPU and memory. These are something called resources. Okay, there is a disadvantage called resource wastage. Okay, let me put resource wastage. Okay, the first disadvantage that we have is resource wastage. Okay, the resource wastage is the first disadvantage that we have. Next, what is the second disadvantage that we have? Okay, now I have 100 microservices in order to deploy, in order to make available to the users. I have 100. Okay, I have 100 microservice, 100 apps. Okay, let me take 100 applications. Now in order to deploy 100 applications on the physical servers, I need more number of physical servers. So that is a second disadvantage I have. If I handle more number of physical servers, the cost will be more for me. Okay, because of this cost, like I need to because of the more number of physical server, there should be a separate team in the organization who will be maintaining that physical servers, and there should be separate place in the organization where we need to deploy that physical servers. So we need to provide air conditioners or power supply and everything we need to provide. So there is a huge cost that will be there for these physical servers if we have. Okay, the second disadvantage that if we deploy the applications on the physical servers is huge cost. Huge cost is the second disadvantage that we have. Okay, that's a second disadvantage. Third disadvantage is the high maintenance. Suppose we have multiple physical servers that is used to deploy our applications, that are used to deploy our applications. So if we have multiple physical servers, we need to maintain that physical server. For each and every physical server, we need to regularly provide the security updates. If any problems appears, we need to regularly handle those problems. We need to keep that physical servers in a secure and isolated manner, so that anyone should not be able to hack that physical server. So there is high maintenance, huge workloads are required to maintain that physical servers. Okay, I should buy a separate place to deploy that physical server. So that's kind of maintenance that comes under. Okay, so third disadvantage, that one we have maintenance. Okay, the third disadvantage that we have is the maintenance. And the next disadvantage that we have, suppose this physical server has been crashed. Okay, this physical server has been crashed. Okay, there is this is a physical server on which our applications are running, right? So if that physical server is crashed, our applications will also be crashed. So there is no high availability for our applications. Okay, there are no high availability. Let me take the text box. Fourth one, no high availability. Okay, no high availability for our applications if we deploy our applications on the physical servers. If we deploy our applications on the physical servers, these are the disadvantages that we have. There are many disadvantages, but let limit it to this. We do not have we cannot discuss all those things, because these are the 4 disadvantages. Let's stick to this. Okay, these are the 4 disadvantages that we have. One is resource wastage, and the second one is huge cost and high maintenance and no like no high availability that we have, that these are the disadvantages that we have with the physical servers. Now, because of these disadvantages that we have with the physical servers, there is something called virtualization has been evolved in the industry. What is virtualization? Let's go through that. Okay, let me put this one at the top. Yeah, like this. Now, what is that virtualization actually? What is virtualization? Let me put here actually. Suppose this is a physical server that we have. Actually, this is a physical server that we have. Let me put it here, the physical server. Okay, okay, this is a physical server that we have. On this physical server contains many things, right? Resources it contains, hardware devices it contains, like disk space and CPU, memory, something. This physical server that contains. Now, on this physical server, we will be having operating system. There is a particular operating system that will be installed on this physical server. Let me take this as OS, operating system. Operating OS, let me put it as OS, operating system. Now, on top of this physical servers, previously used to deploy our applications, but when the virtualization has been evolved, they are deploying something called virtualization software. They are deploying. What is virtualization software, why it is used, let me tell you. Okay, this is something called virtualization software that is deployed on the physical server. Whether it may be any virtualization software, Hyper-V, hypervisor, VMware, VirtualBox, so something like that. Okay, virtualization software, let us think. The virtualization software has hypervisor. Visor is a virtualization software that it has. Okay, what this virtualization software does for us, why we installed this virtualization software on the physical server, this will make us to divide these physical servers into multiple servers. Actually, into multiple servers, this will divide. Let's assume this virtualization software is divided our physical servers into 3 servers. Okay, let me take copy V, control V. Let me put it here. Okay, this virtualization software will help us to divide our physical server into multiple servers. Suppose you might have done some scenarios like you might have installed VirtualBox in your local machine, and what VirtualBox does, it suppose your machine is a Windows machine, that VirtualBox will be creating other machine inside your machine, so that is kind of other server actually. So in the same way, the physical server, let's think this physical server is your laptop, and you have this virtualization software. You just think as VirtualBox, and this VirtualBox is helped us to create multiple servers inside your laptop. Actually, in the same way that works. Okay, so these servers which are created internally in the physical server is called virtual servers. Actually, they are called virtual servers. Okay, these are called virtual servers, something called VMs. Okay, VMs. Okay, this VM1 or VM2 and the VM3. Actually, these are called virtual servers or virtual machines that we call virtual servers. Virtual machines are same. Okay, so virtual servers. Now, this physical server has some, we'll be having some CPU. Let's take the same amount. Okay, 10 CPUs and 10 GB RAM. Okay, 10 GB RAM that are there with this physical server. Okay, now 10 CPUs and 10 GB RAM are there with this physical server, and I will be deploying the applications on these physical servers. Actually, suppose I have deployed the application 1 here, app 1. Previously, if I want to deploy multiple applications, I need to handle multiple physical servers, but in this case, on one physical server only, I can deploy multiple applications. This is application number 2 on the same physical server. Like this is application number 3. Let's think that. Okay, this is application number 3. Okay, let me put as app 1, app 2, app 3. Okay, app 1, app 2, and app3. Okay, these are the three applications. Instead of deploying three applications onto multiple physical servers, in the case of physical servers, we are deploying applications on the one physical servers in the virtual machines inside the physical servers. So because of this reason, instead of buying multiple physical servers, I will only buy one physical server and I will deploy multiple applications on the one physical server. So in that case, the cost will be very less in case of deploying multiple applications on the virtual machines or virtual servers. So the disadvantage that we have with the physical servers is gone in case of virtualization. That is huge cost, right? That is gone. Okay, that is gone. Now the another disadvantage that we have is the maintenance. Here in case of physical servers, previously we discussed, we maintained like multiple physical servers. In order to deploy multiple applications of or all those physical servers, there should be a team to maintain that. But in case of here, we only maintain one physical server for three different applications. Okay, that reduces our maintenance. And if you create these virtual servers on the cloud, there will be no maintenance at all for you. Okay, the entire maintenance of physical servers will be taken care by the cloud people. Okay, you no need to worry. No, now the maintenance is very less and it's negligible in case of virtual servers. Okay, in case of physical servers, in case of virtualization, I mean to say, in case of physical server, the maintenance is negligible because this entire physical server will be maintained by the cloud people only. AWS or Azure or GCP, entire physical server is responsible, like maintenance of this physical server is responsible for like by the AWS team itself. So that's the thing, maintenance is gone. Okay, now high availability. What is there with high availability? Now high availability is like in the cloud, if we create virtual machines or virtual servers, there will be something called auto scaling groups. If this, let's think this virtual server belongs to auto scaling group. Okay, this is something called auto scaling group that we call it as. Okay, auto scaling group. What is the use case of that? What does auto scaling group does for us is, if any server got crashed inside the auto scaling group, then that server will be automatically created and our application will be automatically deployed. So such kind of high availability will be there in case of virtual machines. Actually, if we create the virtual machines in the AWS, so that is the high availability disadvantage that we have with the physical server is gone in case of virtualization and the cloud. Okay, virtualization and the cloud. The left out disadvantage is the resource wastage that we have with the physical, like virtual servers or the virtual machine. This is still there. How it is there? Let's think this physical server has 10 CPUs and 10 GB memory, and let's think this each virtual machine is consuming 3 CPUs and 3 GB memory, 3 GB memory, and this is also consuming 3 CPUs and 3 GB memory. Let me put that one. And this is also consuming 3 CPUs, 3 CPU and 3 GB memory. Okay, so the physical server has divided this its own CPUs and own 10 GB memory into 3 equal parts and given to the virtual server, because these virtual servers are there on that physical server only. They are divided like this: 3 CPUs and 3 GB for each virtual machine. Okay, one CPU is used by the like 1 CPU and 1 GB RAM is used by the operating system and the hypervisor. Just think like that. Only 9 CPUs and 9 GB memory is used by this virtual machines or the virtual servers. Suppose our application is using only one CPU. It may not use one CPU also. Okay, sometimes. Okay, one CPU and 1 GB memory. 1 GB memory. Okay, let me do like this. Okay, 1 GB memory. Now what about remaining out of, if this application uses 1 CPU and 1 GB memory, what about remaining remaining two CPUs are left out and 2 GB memory is left out, right? What about remaining two CPUs and 2 GB memory that is left out with this virtualization, with this virtual machine, actually with this virtual machine? Now this is the resource wastage that is still there with the virtual machine. Okay, this is still there with the virtual machine. One of the reason why we go to Docker is the because of the resource wastage that we have. Okay, one is the resource wastage that we have with the virtual machine, or resource wastage. And the second reason, because of the evolution of microservices. Okay, there are many reasons for that. These are the major reasons. One is the resource wastage, and second one is the microservices. We have seen the resource wastage, how this resource wastage is removed in case of Docker, we will be seeing in the next class, and the microservices architecture also we will be seeing in the next class. Okay, because of these reasons only, see, first, people use to deploy the applications on the physical servers. There are some disadvantages that we have with the physical servers if we deploy the applications there, and because of the disadvantages, people use it to deploy their applications on the virtual servers. What are virtual servers? Physical server is divided into multiple servers. Those are called virtual servers. And there are disadvantages that we have with the virtual servers. And because of that disadvantages, we are moving to Docker. Okay, Docker. Okay, so that's the thing. Docker also gives a high visibility of our applications, and like more insights to our application, something like that. We'll also see what are the these are the reasons why we go to Docker, and we will be seeing how the Docker is installed on the virtual machine and something like that. Okay, so any questions you have, please, you can ask. Any question?
Yeah, I'm having questions. So whenever you are saying this physical server, so what's the role of hypervisor? I mean, could you please repeat? I missed probably that part.
Okay, hypervisor, this is a virtualization software. Okay, like it's a virtualization software. The role of this hypervisor is this will divide our physical server into multiple servers. Actually, like these are multiple servers, these are VMs, that is called virtual servers or virtual machines that we call it as. This will allow us to divide the physical servers into multiple servers. So this is a virtual machine one
Okay,
into virtual
got it.
machine.
Now let's say one one of the application is running on Unix, another one running on Mac, and another one needs an OS of Linux, right?
Okay.
So how this physical server is going to handle in that case?
Yes, we see this physical server will be having OS, right, on this host operating system. This is a OS operating system that we have in this physical server. See, each and every virtual machine has its own OS. Actually, that is called guest OS. Okay, you can install one, like in this Unix you can install, in this Mac OS you can install, and in this like Windows also you can install. So each and every, see, if suppose if you, some people may have downloaded your virtual box in your local machine, right? Suppose if your machine is Windows machine, you have installed virtual box. What that virtual box does, that virtual box allows, that's a virtualization software, like hypervisor only. That virtual box does for us, like it will allow to create Linux machines on your Windows machines. I will be using WSL in my company, Windows subsystem for Linux, but my laptop.
I understand there will be a different layer of software which will convert one ways to another ways, right?
Yes.
So where that layer comes into? I mean, is this after hypervisor? I mean, how
that
this conversion takes
hypervisor
place?
does for us. Hypervisor does for us. It's a software that we install. It's because of the software that we install that will divide for us. Okay, it's not another layer will be there. That's a functionality of the hypervisor that will have.
So it divides the physical resources as well as
Operating system.
the software OS also is just help us to migrate, right?
Yes.
Okay, yeah. So today, is there any other topic to cover? Because I have to step out for a while. That's why I'm just asking.
Oh, time got completed. Yeah, that's why this is open, like open time for questions.
Okay, so tomorrow again 8 a.m. right, sir?
Yes, it's 8 a.m.
Can I drop off now?
Yes, you can.
Okay, thank you, sir.
Thank you. And before
And
going,
sir,
Yeah.
tell me.
before going, I need to tell that please go and register for the course. That's it from my side. So yeah, that I will be telling in every class. So that's the thing. Okay, that's it.
Sir,
Nothing.
what is registered?
Register for the course.
Yeah, I have already registered for the Zoom link and everything. So my thing is that probably after tomorrow's demo, I'll think of this paying and all those things to done. Okay.
Sure. Just my responsibility is to say that's
Yeah,
yours.
And same URL, sir, same Zoom link to attend tomorrow as well.
Yes, same Zoom link. Yes.
Okay. Fine, sir. Thank you. And another thing, sir, so many other cases, what we have seen is, so whenever some less amount of, audience comes in a single batch, that's time batch gets cancelled automatically. So here, this kind of scenario will not happen, right? Because I know Docker and Kubernetes is a bit complex. So that's why few people joins in every batch. So earlier, my experience tells that I registered for a different organization. I don't want to take name. Very less amount of people joined there. I don't know, probably they are looking for some benefits or monetary target that's not filled up. That's why they just canceled the batch. Here, this kind of things will not happen, right, sir?
Not happen here. If one member joins also, I will be continuing with the batch. Okay.
Oh, perfect, sir.
That scenarios will not be there here.
Okay. Thank you. Yeah. I'm dropping off, sir. Thanks for today's lecture.
Thank you. Anyone have any questions? Please be clear. Any questions you have, please ask. You can ask. It's open for questions.
No question from my side, sir.
Is that understandable or
Yes,
how it is?
pretty clear for me. So as I mentioned that I am fresher, but it's fully clear for me what you discussed today. So definitely looking for next classes, how it will go, or else definitely I'll disturb you or I'll ask you a question.
Sure. Thanks for that. If you have any problems, please clear in the class itself. And once you register for the course, you'll be getting the drive access as well as the Telegram group access, so that I will be sharing the link there and you can join the Telegram group. We'll be discussing the rest of the things. And please go ahead and join for the course. If you have any questions, anyone, you can ask, or let's meet tomorrow.
Yeah, so again, is it required to register the class for tomorrow? Yeah, already as I registered, it's not required, right?
For demo, same Zoom link will be there. So if you want to join the live classes after that demos completed, you need to register for the course. Yes.
Yeah, Pakka I'll join, but on tomorrow, sir, I'll decide and I'll pay. But Pakka I'll join.
Sure. It's your option that you can decide. Okay.
Yeah. Okay, sir. Thank you, sir.
Yeah, so my point is that today's session was great actually, and just wanted to reconfirm that the timing will be same for the duration, right?
Yes, timings will be same. It will not be changed. 8 AM to 10 AM.
Yeah. Okay. Thank you.
Thank you very much, sir, for today's class.
Thank you. Please go ahead and register for course. So that I need to say, thanks for joining session. Have a good day.
Thank you.
Thank you.
Bye-bye.
Thank you. Bye-bye.